lecture, let us discuss about alpha beta pruning. We can say that this is an optimization technique which is used for minimax algorithm. So we already saw what is meant by minimax, right? It has to examine our exponential in depth of the tree. So there we cannot eliminate the exponent, but we can cut it to half. So there is a technique by which without checking each node of the game tree, we can compute the correct minimax decision. So that technique is nothing but pruning. So which involves two threshold parameters, that is alpha and beta. And that's the reason why this method is called as alpha beta pruning. So it can be applied to any depth of the tree, and sometimes it not only prune the tree leaves, but also it is even used to prune the entire subtree. So the two parameters that we use are alpha and beta, right? So this alpha, this is the best or the highest value we have found so far at any point along the path of maximizer. So the initial value of alpha is minus alpha. And beta, we can say that this is the best lowest value that the minimizer can guarantee, or we have found so far at any point along the path of the minimizer. And the beta value, initial value of beta is plus alpha. This alpha beta pruning returns the same move as a standard algorithm does, but it removes all the nodes which are not really affecting the final decision but making the algorithm slow. So by pruning these nodes, it makes the algorithm fast. These are few important points in alpha beta pruning. So this method is actually used in order to find the optimal path without looking into each and every node in the tree. And max, it always contains alpha, whereas min contains beta values. So in both min and max node, we'll check the alpha and beta values. So we'll compare the value of the leaf node with the parent node, which are represented with alpha and beta. If this condition is satisfied, if alpha value is greater than or equal to beta, then we'll return the value to its parent node. So we'll see this point in the example. And both this mini max and alpha beta pruning, both of them, they actually gives us the same path. But the difference is this alpha beta pruning provides solution within less amount of time, as we prune all the unnecessary paths. Paths. Let us see this example. It contains max node and min node. In mini max or alpha beta pruning, we use DFS algorithm to search the paths. So here also we'll search the left subtree first unless or until we reach the leaf node. So let us search the left subtree, move from A to B, then from B to D until we reach the leaf node. So when we reach the leaf, it has 4 which will be returned to its parent. So 4 will be returned to its parent. So which is nothing but the max value. So this is max, which is represented with alpha. This is min, represented with beta. And again, this is max. So you can even use different symbols in order to represent this alpha and beta. Now we traverse towards left part. So you need to decide whether to traverse to the right part or not. So in order to make that decision, we need to compare this node to its parent. Compare this value B4 to its parent. Parent is not having any value. So as we don't have any value, we need to search towards right side. So compare this 3 with parent value 4. So here in this level, we are considering alpha values. So that is max values. So among 4 and 3, maximum value is 4. So this 4 will be retained at this point. And you need to return this 4 to its parent. Right? So this left part is over now. Then again, have to decide whether to traverse towards right side or not. So for that, we need to compare 4 with its parent. So compare 4 with its parent. So here this parent node is not having any value. So you need to traverse towards right side. So move towards right side. Now, so we have 6, right? So return this 6 to its parent. So 6 is returned to E. Now have to decide whether to move towards right side or not. So here you need to compare this value with value of the parent. So here alpha value is 6 and beta value is 4. So what is the condition? For alpha is greater than or equal to beta. So 6 is greater than or equal to 4. So as this condition is true, you need to return value to parent. So return this 4 to its parent. So now no need to traverse towards this right part as this condition is satisfied. So here this path is pruned. Now go to right part of the tree. So go to right side. Move to this left part. So here return 2 to its parent. Parent is F. As parent, that is min of B. So here after returning this, we need to decide whether to traverse towards right side of F or not. For that, we need to compare the value of F with its parent node. So this parent is C. So as parent doesn't have any value, we cannot compare 2 to its parent, right? So you need to move towards right side of the node F. Now among these two, find out the maximum value at this level. So maximum value is 2. So retain 2 at this node 5, node F. So 2 is retained and return this 2 to its parent. That is min of beta. Now again have to check whether we need to traverse towards right side or not. So you need to compare this value, alpha value, this beta value and alpha value. As alpha is greater than beta, this path will be pruned. So no need to traverse towards right side of this node C. So now what is parent? Parent equal to 4, which is the final value for this 2-player game tree. So we have pruned few paths which are unnecessary. So what are the paths? We pruned this path and we pruned this complete right subtree of this node C. Here we can say that path with 4 is the optimal path. So this is the optimal path. This root node has to follow in order to win the game.